once the caterpillar's former body has dissolved, the protein in the caterpillar soup becomes fuel for the imaginal discs. Now these discs begin rapid cell division, with each disc specializing in some part of the butterfly to be. Some discs become eyes, others become wings or antennae. Clusters of imaginal cells in increasingly organized structures begin exchanging information, connecting together, forming networks. Diversity within community is the order of the day, and there is room for everyone. An eye does not need to become a wing, for example. Each is important, and a butterfly needs them all. And now I'm going to do something you possibly don't usually hear at this kind of reading. I'm going to read to you from a textbook. So I'm going to read just a few excerpts in no particular order from this textbook. And this first one is from the chapter on green building design. In a beautifully designed high-rise dwelling in the African desert, residents cultivate food crops in the lower levels. Without electricity, they use precisely tuned stack ventilation. I'm going to tell you some technical terms. Stack ventilation is one. So without electricity, they use precisely tuned stack ventilation to maintain their gardens and their living spaces at just the right temperature, humidity, and carbon dioxide level for themselves and their crops. An underground cellar is the coolest area in the structure, kept cool using evaporative cooling. As heat flows up through the tops of solar chimneys, cool air from the cellar is pulled through the living quarters. Design strategies of thermal mass, stack ventilation, solar chimneys, and night flushing keep conditions constant inside, while temperatures outside in this desert climate fluctuate from 107 during the day to 37 degrees at night. The inhabitants of this structure are mound-building termites. Systems. The study of sustainability is the study of systems. A system is a set of interconnected elements that constitute a whole, where the identity of the whole is always more than the sum of its parts. The properties of the whole cannot be predicted by examining the parts. They are emergent properties. They arise or emerge from the interactions of the parts. The lack of a sharp distinction between individuals and communities is a feature of life on Earth. In societies of social insects, such as mound-building termites, individuals do not make voluntary decisions in the same way we do. They are part of cooperative communities where their behaviors are orchestrated by exchanges of chemicals, resulting in what at first look like random patterns, but which turn into emergent organized wholes. None of these individual insects knows how to make a complex, highly structured, perfectly air-conditioned termite mound. Yet these structures always emerge out of their interactions as a community. Whether a human body, a termite mound, an ecosystem, or a planet, systems cannot be understood by studying the parts. The processes that make a living system only take place when the individual parts interact together. It is a feature of all emergent systems, of all life, that the whole is always greater than the sum of its parts. Resilience. Sustainability work includes the concept of resilience, the ability to cope with change. Resilience, and this is the scientific definition, resilience is the capacity of a system to accommodate disturbance and still retain its basic function and structure. Like a forest does when a tree blows down, but the forest goes on. In a forest, things change all the time. Wind blows a tree down. It stops being a tree, but on the ground it goes through a series of transformations, becoming home for thousands of creatures in successions of generations. The tree blows down, a sunny spot opens up, and new kinds of things start growing. Mosaics of different kinds of plants and the animals who live with them are constantly appearing and disappearing, but the forest itself is still a forest. Why is it resilient? Because there are so many different kinds of creatures there, each making its living in its own way. It turns out that diversity is the key to the resilience of systems. Whether we are talking about people or nations or forests, the more diverse a system is and the more variations there are, the better the system will be able to deal with change and stay resilient. There are many ways to be. There are many directions in which to work. And like a forest with many creatures making their livings in many different ways, we need them all. Now from a chapter on ecosystems and habitats, wilderness or managed landscape. It is a common belief that there are two types of landscapes: pristine wilderness and places impacted by humans. But we have to go far back in time to find habitats not impacted by people. Humans and ecosystems have lived in interconnected relationships for thousands of years. North America, for example, was heavily managed by Native American people who lived there using fire and other techniques. In 1492, European explorers arrived on the shores of a managed landscape where for centuries humans had modified vegetation and built earthworks, roads, and cities. Those voyagers brought with them diseases against which local people had no resistance, and as a result, native populations fell by 90%. Without the human land managers to burn, clear, and plant, trees filled in the cleared places and dense forests formed. 300 years later, this was the landscape Euro-American travelers saw, a regrown forest they thought was wilderness. In what is now the Amazon rainforest, archaeology has uncovered evidence that complex societies once managed large farms and orchards and built cities, roads, and water systems. Spanish explorers wrote about the urban centers and highways they found there. Spanish explorers also brought disease, launching a pandemic that wiped out 90% of those local populations. The forest took over, and the few survivors fled into the jungle to become the remnants of isolated tribes we find today. In the Amazon basin, what we now think of as pristine rainforest was, until 500 years ago, the managed open landscape of a sophisticated civilization. Novel ecosystems, and this is a scientific term also. Is a species native or non-native? Well, it turns out the answer is not clear-cut. Species constantly change, adapt, and form new relationships. Camels were originally native to North America, but around 4 million years ago began migrating elsewhere. The mammoth, a kind of elephant, was native to Asia, but during one of the ice ages walked across a land bridge to North America and settled in. Later, an invasive species, Homo sapien, hunted it to extinction. Humans themselves were native to Africa, but later spread to other continents. Meanwhile, ranges of plant species have shifted repeatedly over time as temperatures grew warmer or cooler, glaciers advanced and retreated, landforms rose and eroded, rivers changed course, with combinations of species constantly shifting and remixing too. What is now the open rolling countryside of Britain was covered in forest 5,000 years ago. 15,000 years ago, it was covered in ice. And before the last ice age, Britain was home to hippopotamus and lions. Throughout the history of life on Earth, species have constantly moved about and communities have constantly reorganized, always in novel ways. The traditional view of ecology was that ecosystems are stable and balanced. We now know that they are dynamic and somewhat unpredictable. Life continuously innovates and generates novelty as it explores new niches and adapts to shifting conditions. Conservationists often work to return an ecosystem to some state in the past. We remove non-native species. We reintroduce species which have disappeared, in the belief that places that look like the past are more natural or more wild. Life moves on, however, and many changes are irreversible. Today, global climate is changing. Plants and animals are adapting by shifting their ranges toward the poles and higher in elevation. As they do, the combinations of who lives with whom are shifting too. The details may be novel, but the movement of species is not new. Many species shift hundreds of miles every time ice ages come and go, or climate warms or cools. Meanwhile, human activities have moved all kinds of species to new locations where they have adapted and settled in. The new communities being created are known as novel ecosystems. Of course, species and habitats have continually changed throughout the history of life, so every ecosystem was a novel ecosystem at some time in the past. Systems allowed to operate on their own will drift into new and unprecedented states as species move and remix. This is the new face of the science of restoration ecology, as ecologists incorporate concepts of change and resilience, which are fundamental features of living systems. This is from a chapter on history, the Anthropocene. Humans have become a geological force on a planetary scale. Geologists divide time on Earth into periods based on physical characteristics of geology, climate, and life. The Holocene was the 10,000-year epoch spanning all of written human history until now, a time between ice ages where a warm and unusually stable climate allowed civilization to develop. These rare, extraordinarily stable conditions made it possible for population to grow, agriculture to appear, and human cultures to arise and flourish. Research shows that without human influence, the ideal conditions of the Holocene would probably have continued for several thousand years more. But human activity has become such a powerful force that it has major planet scale impact on climate and every living system. And so we now live at the beginning of a new geological epoch known as the Anthropocene. The word comes from two Greek words, anthropos, or human, and scene, new or recent, Anthropocene. Each time period leaves behind a physical signature in rock strata that will still be visible in the geological record millions of years from now. The official body which establishes the geological timescale is known as the International Commission on Stratigraphy. Their subcommittee, the Anthropocene Working Group, is now studying whether to designate a new epoch and working out what physical evidence should be used as its marker. The term is already used by scientists, many of whom agree that Earth has entered the Anthropocene. An official decision is expected in the next year. Oh, I should define a term that you'll hear in here. You may or may not have heard it before. The term is biosphere. So the biosphere is that thin layer at the surface of the planet where life lives. And it consists of living things and all the living and non-living elements that interact together, that make up the Earth system. So that's the biosphere. Living in the Anthropocene. We live on a changing planet that is fundamentally different than it was when any of us were children. In the last 50 years, population has doubled, consumption of water has tripled, the use of fossil fuels has quadrupled. The planet's sixth mass extinction is underway, with 50% of species alive today predicted to be gone by the year 2100. Sorry, that always gets to me. The Holocene has apparently come to an end, and humanity faces a mix of novel conditions it has not encountered before. We face extinction, resource depletion, climate destabilization, social inequity, and failing states. These interconnected problems are complex and continually evolving. Behind them all lie two fundamental drivers: human population growth and consumption, built on the economic growth model. The question is not whether we will change, but how, and what form the transition will take. Navigating the shifting conditions will require transformations in the social realm, while we somehow avoid crossing planetary scale thresholds in the biospheric realm. We will need to find ways to live better and work together like never before. We will need to shift quickly away from fossil fuels. We'll need to reduce consumption, provision ourselves from zero-waste economies, reduce population growth, and provide food to growing numbers of people without converting new areas of land or destroying habitat. We will need to live within the planet's capacity to support us and our fellow creatures into the long-term future. We will need strong communities, networks of all kinds, and participation in governance at multiple scales as we build the foundations for a thriving, sustainable human civilization and biosphere. Humans have gone through several major transitions in their history: the discovery of fire, the development of language, the development of agriculture and civilization, and the Industrial Revolution. Today, we live on the threshold of the fifth great turning, a turn away from a fossil fuel-powered, climate-destabilizing, growth-based industrial economy and toward a sustainable, regenerative world. And finally, this is the last section, climate change. Planet Earth has what is called climate commitment. We are now committed to a warmer climate because of the increased amount of carbon dioxide already released into the atmosphere. And after 2 centuries of fossil fuel consumption, science tells us that the climate system has become destabilized. Still, there are grounds for hope. If we are very committed, soon enough to avoid tipping points, the climate will eventually stabilize, and the CO2 concentration in the atmosphere will begin to fall to a safe level. At that point, assuming that geochemical cycles, remaining ecosystems, and other planetary components have stabilized, the parts of the Earth system that survive will be able, slowly, to soak up the excess carbon dioxide and restore balance. However, much will have changed. Earth, when it settles into a new state of dynamic equilibrium, will not be the same as it was before. Between now and then lies the transition. That is where we live now. The transition back to stability will take centuries. Scientists tell us that the climate impacts of fossil fuels are expected to last hundreds, but probably thousands of years. The work we do now is for a future we will never see. This work, contributing to the stabilization of Earth's climate to maintain livability of the biosphere for us and so many fellow creatures, may be the most consequential work any of us will ever do. And Godspeed.